Geometry 1-5, angle relationships. So here we're going to learn a bunch of vocabulary about having to do with the relationship of angle pairs, angle relationships. First off, we have adjacent angles. So adjacent angles, they have a common vertex. And they have a common side. So let's draw a couple adjacent angles. So this might be angle 1 here and angle 2. Notice we've got a common vertex and a common side. And another way you might see this is something like this. 1 and 2. We've got a common vertex and a common side. So we've got angle 1 and angle 2 are adjacent angles. Now over here on the right hand side, we're going to do some non-examples. These are not examples of adjacent angles. So here, here's one. If we have a line like this and a line going out right here, and this is angle 3, a line going over here, that's angle 4. Notice how angle 3 and angle 4 do not have common vertex. They do not have a common vertex. Now here is another one. Let's look at this. So I've got, now look, you might see, oh look, Mr. V, but this looks exactly the same as this one. Just wait a second. Let's label this A, B, C, and this is angle 3. Notice how ABC is not adjacent to angle 3. It has a common vertex. It actually does share a side, but angle 3 is contained inside of angle ABC. So it's not adjacent. So angle ABC and angle 3 is a non-example of adjacent angles because angle 3 is inside of ABC. All right. Linear pair. Let's just draw an example of a linear pair. Here's a line. Here's a ray coming out of the line. Here's angle 1 and here's angle 2. Angle 1 plus angle 2 equals 180 degrees. So if I add these two together, you get 180 degrees. This is a line. So angle 1 and angle 2 are a linear pair here. Now let's look at this. Let's draw another non-example. We can label this B, D, A, C. Notice how we have like a vertex here, but we don't have a line. So if I added these two together, it would be greater than 180 degrees. This is not a line. This is not a linear pair. Next, vertical angles. Vertical angles are when I have like an X. And I've got angle 1 up here, and angle 2 down here, angle 3 on the left, angle 4 on the right. Angle 1 and angle 2 are vertical angles. They're across from each other. They share a vertex, then they are across from each other. Angle 3 and angle 4 are also vertical angles. They are across from each other, across the X, if you will. Here's something special about vertical angles. Here's what's special. Vertical angles are congruent. That means that measure of angle 1 equals measure of angle 2. and measure of angle 3 equals measure of angle 4. Vertical angles are congruent. Now here's a non-example. If I draw an angle here like this, and I draw another angle here like this. Notice how it kind of looks like an X, but it's not quite. It's got to be two straight lines that cross each other to get vertical angles. Next, complementary angles. Complementary angles. Complementary angles. So I'm going to draw a right angle, and I'm going to draw a ray that's in here. This is a right angle, and this is angle 1 and angle 2. Here we have angle 1 and angle 2. Angle 1 plus angle 2 equals 90 degrees. Let's do another one. I have this angle here. That's angle A. And then another angle here. That's angle B. Angle A is 25 degrees, and angle B is 65 degrees. If I add those together, angle A plus angle B equals 90 degrees. So, what can you deduce a complementary angles are? Or how do you know if angles are complementary? You know they're complementary if they add together to be 90 degrees. So angle 1 and angle 2 are complementary. Angle A and angle B are complementary. Notice how they don't have to be touching to be complementary. They just have to add together to be 90 degrees. I didn't put together any non-examples for that one, but let's look now at supplementary angles. Supplementary angles, I'm going to draw a line like this. I'm going to draw a ray that comes out there, and I've got angle 3 and angle 4 here. If I add angle 3 and angle 4 together, measure of angle 3 plus measure of angle 4, I get 180 degrees. When I add these two together, they are 180 degrees. They are supplementary. Now you might remember, look, angle 3 and angle 4, they are a linear pair, just like angle 1 and angle 2 are. So in this example, you add these together, it's 180 degrees. It's a linear pair. A linear pair is a pair of supplementary angles. A linear pair is supplementary. But you could also have a 60 degrees angle, angle Q, and a 120 degree angle, angle P, and angle Q and angle P, they're supplementary. They're not a linear pair, but they add together to be 180 degrees, so they're supplementary. Now, I did this graph thing here, and I need to make a little adjustment to it, and that is we are going to add perpendicular angles to it right here. Perpendicular. To this chart. Perpendicular, it's on its own. It's not a non-example, it's its own example. So a symbol for perpendicular angles is like this. It's like an upside down flat T kind of. So let's draw perpendicular angles. Now I've taken one line that's straight up vertical and another line that goes straight horizontal. This is angle point A, point X in the middle, down over here at the left is D, down at the bottom is C, over to the right is B. Now I'm going to say that line AC is perpendicular to line DB. And what I mean by perpendicular is these two lines cross at a 90-degree angle. So should this say perpendicular lines? Perpendicular means that these two lines cross at a 90-degree angle. Perpendicular lines. Okay. Now all of these are going to be 90 degrees here. But we only need to mark one because we know that they're all 90. Okay. Next. Let's do some examples of this. Okay, so I've got supplementary angles. I've got a pair of supplementary angles. And the difference between the two is 18. So I've got to figure out how am I going to take supplementary. I'm supposed to find each angle measure. So if you remember, supplementary angles are kind of like, one plus the other one equals 180 degrees, right? So I say A plus B equals 180 degrees. Now we can go through some different ways of doing this. Here's the way I suggest you do these examples. I know that supplementary means 180 degrees. And I know that the difference is 18. So here's what I'm going to do. I'm going to try to make this as easy as I can. I'm going to say 180 minus 18, because that's what the difference is, minus 18. So that's going to give me 162, right? Now, that's how much is left over after this difference. I'm going to take this 162. I've got two angles here to deal with. So I'm going to divide this by 2. If I divide 162 by 2, I've got 81. So one of these angles is 81 degrees. And then one of these angles is 81 plus 18. See how the difference is 18? I subtracted that out a while back. So one of them is 81, and one of them is 81 plus 18. So if I add these together, 81 plus 18 is 99. That gives me 180. So one angle is 81 degrees, and one angle is 99 degrees. And if I subtract them from one another, I get the difference, which is 18 degrees. So if that didn't make sense, rewind, watch that again, and see if maybe I made more sense the second time. Here is a U-try. Now we're going to stop at the bottom of this page. So we're going to do this U-try, we're going to do another example, and we're going to be done. U-try, complementary angles is what you're going to start with. Complementary angles. The larger angle is 12 more. Larger angle is 12 more than twice the smaller angle. Phew. Okay, so before you get started, you've got complementary angles. So look back on the other side and see what that means. What does complementary mean? and then see if you can figure this out. Okay, pause now. Okay, let's see how you did. This one maybe was a tough one. So I'm going to start complementary angles. I've got complementary, which means 90 degrees. If I add them together, I get 90 degrees. So this equals, so I'm going to say, I'm going to call one angle, angle A. And I'm going to call that one the smaller one. Let's say the smaller one is angle A. Okay. So I'm going to say, if I add these two together, it's going to be angle A, that's the smaller one, plus angle B. Now, I know that angle B is 12 more than twice the smaller one. And so that means I can say twice the smaller one, that's 2 times the smaller one, which is angle A, plus 12 more, plus 12. So now I just have to solve for angle A. And I just think of angle A as x. And then I solve for it. So I've got 90 equals 2a, or 2x, 2 times angle A plus 1 angle A. That'll give me 3 angle A. 3 angle A plus 12. Subtract 12 from both sides. This will give me 78 equals 3 times angle A. I divide both sides by 3. Angle A then equals, what is 78 divided by 3? Let's see, 20. 26, right? Angle A equals 26. Yep. So that gives me my smaller one. That's the smaller one. Now the larger one is this with the angle with 26 plugged in for A. So this is the smaller angle, this is the larger angle. So I just plug 26 back in. 2 times 26 plus 12. So 2 times 26 is 52. 52 plus 12 equals 64. So larger is 64. And that is how you do that one. All right, let's do a different example. Let's draw a line and a line and a ray. Let's start labeling this. P up here to the right is Q, down here toward the bottom is R. The end of this ray near the end is W. Not really near the end because it goes on forever, right? Up here is S. In the middle here is T. And then I've got STW is 2x degrees. And WTR is 5x plus 6 degrees. Oh, and one more. 4y minus 2 degrees is this PTQ. Okay, now here's what we're going to do. We're going to find x and y so that PR, line PR, and SQ are perpendicular. So here's what we have to do. First, we have to find what x equals. So we're gonna say that these two lines are perpendicular, meaning that this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. So I'm going to take this mess I'm going to set this equal to 90 degrees. 2x plus 5x plus 6 equals 90 degrees. So I just take all of the angle measures in here, add them up to be 90 degrees. Now I solve for x. 2x plus 5x is 7x, and I want to subtract 6 from both sides, so 7x equals 84. Then I divide both sides by 7, x equals 12. 84 divided by 7 is 12. So x equals 12, and now I need to find out what y equals. Now again, I just want this to be 90 degrees, so I just say 4y minus 2 equals 90 degrees. Add 2 to each side. 4y equals 92. Divide by 4, divide by 4. Y equals 92 divided by 4, which is 23 degrees. And that is how you do that one. I just set those equal to 90 degrees because I want to make sure that these are perpendicular. And that is the end of 1-5.